Okay, 4.6 number 3 states that you have a box sitting on a frictionless surface. So we have our box, we have Fn because we're sitting on the surface, we have Fg acting down. The other thing is we have a 100 Newton force pushing down into the box at 30 degrees below the horizontal. So if we set up our components, it would go this and there, and that angle there would be our 30 degrees. Okay, so I went ahead and wrote our givens. Our force applied that pushed down into the box is Fa. Our mass is 30 kilograms, and our Fg here is 294.3. Normal force, applied force. So we want Fn, we want Fa, our acceleration, and velocity at 5 seconds. All right. So these are all the things we're looking for. So after we draw our box and list our givens, first thing we do is our net force equations. F of x is, since we're frictionless here, we just have this one force acting on the x. So that would be Fax. And that's equal to a value because it can't be at equilibrium if there's just one force there. All right, and then at sigma in the y, we have Fn acting positive. We have Fg acting down. And we also have that Fay, that component there, that's acting down as well. So that would be Fay. And since we're sitting on the surface, we can state that that is equal to 0. Okay, so we want our Fn. We just do our algebra. Add Fg, add Fay. Okay, we have our value for Fg. Our Fay, where to put this? I'll put it down here. Fay is just our component, so we're looking for this side, which is opposite. So Fay would be equal to Fa sine of the angle, so 30 degrees. So Fay is 100. That equal to 50 newtons. Okay, so Fg 294.3 newtons plus 50 newtons. And so our normal force here is 344.3 newtons. Okay, so our applied force, how does it word it? Applied force, does the applied force increase or decrease the normal force? So it increases it, right? Because this applied force here, it's in the same direction as gravity. So Fn goes up if that applied force increases. If it was the other way, this normal force would go down. Okay, now it's asking what the acceleration is. This is balanced, so it's not accelerating in the y. This is unbalanced, so we have an acceleration here. So our net force here is Fax, which is Fa cosine of 30 degrees. So 100. And that equals 86.6 newtons. So that's our net force acting on the mass. To find the acceleration, F equals ma. So our net force divided by m. So 86.6 newtons divided by 30 kilograms. We get, we'll round it, A equals 2.9 meters per second squared. All right, so I'm going to leave that there. This is just a kinematics problem. So what's your VF if it starts from rest? So your time would be 5. This would be, it would just be VF equals V naught plus AT. So 0, that value, and then time 5 seconds.